name's Tim Walker. I'm pleased to be here with you today at the SMPTE Toronto Technical Conference 2021. I'm here to speak with you about HDR productions and conversion techniques. So again, my name's Tim Walker. I'm a product manager with AJA Video Systems, look after a number of their products, including the FS-HDR. I'm also a SMPTE manager out here in Sacramento. And in the past, I've been a product manager for Grass Valley, looking after production switchers. I've been a product manager for Miranda and Envision, looking after the Envision series of routers. I've got a degree in mechatronic engineering from California State University, Chico, where I had the opportunity to actually study abroad in Germany for some of those engineering courses. But enough about me, let's talk about HDR. So we know that live productions are growing in popularity. We're seeing more and more of them. Broadcasters, rights holders, they're trying to get more eyeballs on the content. And what's developed out of that is this idea of single master HDR workflows, and they're becoming more commonplace, and we'll talk about what they are. For those workflows, you're doing a lot of conversion. You're converting SDR signals to HDR, and you're converting HDR signals to SDR. And we'll talk about some of the techniques available for those conversions. And these productions are still evolving. So I want to speak with you about a few of the pitfalls and challenges that I've taken note of and would like to share with you. So let's get started. So first, you can't talk about HDR with a little bit of vocabulary. So here we go. HVS is standing for the Human Vision System, which you can think of as about color relationships and how the brain interprets colors and how the eyeballs actually work to stimulate the response in the brain. And studies have shown that the human vision system has about 30 stops of dynamic range, but you're only really looking at about 14 of those stops, a range of 14 at any one point in time. So when we talk SDR, standard dynamic range, about 5 to 6 stops of dynamic range, which is about what an SDR TV is capable of. And HDR is high dynamic range, and HDR TVs today, are about between 12 and 16 stops of dynamic range. And this is really just talking about, from the darkest darks to the brightest whites. That's what we're talking about with dynamic range. Then you've got color spaces. So you've got the BT709 color space, which is commonly associated with standard dynamic range. And then you've got the BT2020, which is a larger color space, much larger color space, and is really commonly associated with HDR. WCG stands for wide color gamut, which is also associated with HDR, but is really referring to the BT2020 color space. And a lot of people today, they talk HDR, and when they say HDR, it's inclusive of this wide color gamut aspect as well. A couple different curves to talk about. You've got the hybrid log gamma, or HLG, which is a curve that is got basically the same gamma curve as SDR, but then it's got it's hybrid, so it's got a logarithmic kind of top end to it to manage more of the brighter brights of the picture and get more of that information into the signal. There's no metadata associated with it, so don't have to worry about that. And it has about 17 stops of dynamic range associated with it. Then you've got PQ, which is the perceptual quantizer. This was developed by Dolby, and there's different variants of it depending on where it's used in the production to delivery to the home. But you can think of it as a code efficient curve, which does have some metadata associated with it, but because it is code efficient, you can get, a wider, really total dynamic range of about 28 stops. Granted, the TVs can't display that full 28 at one time, but that's what it's capable of doing. Okay, now we've got algorithm. So an algorithm can be thought of in this context as a process to execute a complex set of equations, not just a simple single equation problem, but a complex set of equations and a process to step through those. those equations, versus a LUT. So a LUT is a lookup table, which is a fixed kind of calculation. It takes in one thing and you get something else out on the other end. That's the most generic description of what a LUT is. Then you got a couple different conversions. You've got scene light conversion. So I'd say think camera conversion when you think about scene light conversion. That's how I relate to it. And then display light conversion, I just would think in terms of the workflow, think that you're going to be converting graphics or graded content with that type of conversion. And there's different philosophies on that, so it still isn't settled. So some of the early tests of SDR and HDR workflows had really complex production. So looking at it briefly here, you've got SDR sources going into an SDR production switcher to get your SDR outputs. Maybe pick up an HDR camera, send it through an HDR to SDR converter, get it in the production switcher and switch it. Then you want to do the HDR production at the same time. So now you've got your HDR cameras going directly into it, and every other SDR source you have needs to go through a converter to get into the production switcher. Then you've got all your HDR deliverables. Maybe your HDR and SDR production switcher are tied together, working in kind of a ganged mode, but still you've got twice as much router, twice as much switcher, ultimately twice as much power. It's just not very economical. You may have some more bodies in there as well to assist with the production. So, the way more commonplace now, the more modern single master HDR workflow simplifies all this. You've got an HDR production switcher, you're bringing in SDR sources through converters, you've got your HDR cameras that are going directly into the box, and you got HDR deliverables on the output. The concept here is that everything that's going into the production switcher has the same color imagery and has the same transfer characteristic, so they can be mixed together without having any significant issues. And you'll have a nice you'll have a nice program output, which can then be converted to your different deliverables on the output. So simplifies things, less equipment to manage. So the different conversion techniques that are available, we've got these algorithmic converters, which again are executing complex sets of equations to move through the transform. But these transforms can accommodate or account for lots of different factors, human visual system, phenomenon, that type of thing. They also have the potential for some parametric adjustment. You want to tweak a little knob there, you want to do this and create a look there, you have the ability to do that. Lookup tables, which are LUTs, those are again fixed. They're fixed, they take in a value and they spit out a value. But there are differences. You've got different sizes of LUTs with 1D LUTs versus 3D LUTs. You've got 17 point versus 33 point, and you also have 65 point in some other software-based type applications. Then you've got interpolation. You've got trilinear versus tetrahedral. Some things to talk about. I won't get in the details of the mathematics there. But to look at an example of an algorithmic converter, we can look at the ColorFront engine. So this engine developed by ColorFront. One of them is one of the engines has a TV mode, and the ColorFront engine is a perceptual processor taking into account lots of aspects of the human vision system to create these different conversions from SDR to HDR, HDR to HDR, HDR to SDR, and then also the idea of round tripping, which is the idea of taking an SDR signal, making it HDR, and then coming back to SDR with minimal impact to the original SDR content, colors, and relationships. But this engine is designed for television broadcast, and it's got some specific tools for that. It's got a customizable knee point and knee slope control, which can help manage highlight and roll-off, gamut roll-off. It's got a color corrector built into it, and it's got a camera correction capability for some scene referred adjustments. There's no metadata associated with it, and the reason I mention no metadata is there's a lot of equipment out there that historically has stripped metadata. It's not something that gets passed through end to end, so if you're relying on it, you might not always get to the places that you need it to. So having no metadata isn't a bad thing. Benefits, yeah, the algorithms are processed in the perceptual space, which takes into account some of the phenomenon associated with the human vision system. It maintains these critical relationships between colors and tone scales for the different deliverables, ultimately maintaining the original intent of the creative that came up with the content. And it focuses on creating a pleasing picture, a beautiful picture, if you will. So looking at a couple of examples here of the HLG to SDR down conversion on the left-hand side, just doing a straight conversion. It clips the top end, which is adhering to the BT 2408 guidelines, which is great. Anything above 203 nits is clipped. Works for some certain applications like matching an HLG to an SDR camera. But if you're really doing an HLG to SDR down conversion for delivery or a deliverable, you may want to touch the knee point and knee slope control so you can bring the red and green values in this case down and manage the roll off and highlights so you can retain the color and relationships and recover some of the detail and have a nice looking SDR deliverable. On the other side, going from SDR to HLG, in default mode follows BT 2408 guidelines, maps 100% white to 203 nits. And this is great for, maybe up converting some SDR graphics to get them into the HLG BT 2020 color space so they can be mixed in an HLG program with little impact to the actual signal. But if you wanted to, you could adjust the knee point and knee slope and expand some of the highlights and colors into the BT 2020 color space. You might want to do that for up converting cameras, and on the right is an example of that. But bottom line, bringing this back into the single master HDR workflow, these algorithmic converters can be placed anywhere you'd have an HDR converter for cameras, replay, graphics, and all the way at your output for creating your distribution formats. Now looking at your LUT-based conversions, one example of those is the BBC HLG LUTs. So these were developed by BBC R&D and NHK. I won't get into the details and the history of it, but they convert the same signals that the SDR to HDR, HDR to HDR, HDR to SDR, and also provide some round tripping capabilities, which actually came in some of the newer versions. There's more focus on it in some of the newer versions from the BBC. But they are designed for television production, more of a focus on live television production recently. There's 20 LUTs that are available, both scene light and display light conversions are there. LUTs for many different signal types and requirements. I'll show you something on the next slide which shows you how expansive the possibilities are. There are no controls to modify the look because it is a LUT. So the converter that you use that has the LUT in it may offer a RGB color corrector or proc amp so you can adjust the signal before it enters the LUT, which would be a good thing to do. And it also requires no metadata, again, not a bad thing. Benefits are, it's got some associated LUT pairs to ensure the best possible round tripping if that's a requirement for you. The human vision system has been taken into account into the mathematics behind the LUTs, and there has been a thought to protect the SDR through their mathematics, which is fine, which is great. And it's a LUT, so you just set it and forget it. There's no customization, so some people really like that as well with a lookup table. So here's a table from some of the documentation that the BBC provides for their LUTs. And I won't go through it in detail. It just explains where the LUTs can be used. It shows you across the top the type of, whether it's scene light or display light, whether it clips or not, and down the left-hand side shows you, what kind of content you might create, you might transform with it. So whether it's graded content, cameras, graphics, or programmatic output. So these LUTs can be used in a single master HDR workflow and have been widely used like this in the recent past. So, and still today. So you've got the LUTs that can be the scene light conversion LUTs you might use for your cameras, replay machines. For graphics, you may use the display light conversion, LUT number 3. And similarly on the output, you can have different LUTs for different applications. But all works with a single master workflow concept. Then you've got another LUT-based option or example to consider, which is the NBCU LUTs. So these LUTs were developed by NBC Universal in collaboration with Chromorama and some other industry leaders, thought leaders, had input into the creation of these LUTs. And they also do SDR to HDR and all the things we've talked about before. And they're designed for live production as well. There's 6 LUTs that are available. They support scene light and display light conversions, but they had a different approach to the design and their goals. And one of them was they wanted to make sure they had a knee point which left some latitude for camera shaders to be able to manage some of those highlights depending on the scene that they're shooting. They wanted to make sure that round tripping was a top priority, being able to go from SDR into HDR and back to SDR without any changes, perceptible or even down to the code value. And they developed some tools to measure some of that, taking out, making a measurement that was all about the numbers and less about perception. And so with these, again, there's no metadata associated with it. They try to maximize the dynamic range and color volume available within HDR. And again, it's a LUT, so it's set and forget. So the LUTs, they've got 6 of them. Don't be confused. There are LUTs 1 through 5 here, and then LUT 7. There currently isn't a LUT 6, but I could imagine there would be one in the future. But yeah, you've got LUTs that go from HLG to and from SDR, LUTs that go from PQ to and from SDR, and then you've got an HLG to PQ LUT, which would be used for distribution. PQ is the common kind of distribution format for HDR. So the NBCU LUTs and how they fit into a single master HDR workflow, they've got some documentation, supporting documentation to outline where they would use these, and this is just kind of a snippet and how it fits the diagram for this presentation. But scene light converter for SDR cameras, display light converters for some of the replays, graphics, as well as the outputs that are down converting from HLG to SDR. So everybody's it doesn't matter if you're using algorithmic or LUT-based conversions, the concept of the single master workflow is something that the industry is widely adopting. So some challenges to consider. So we've got cameras with HLG and SDR outputs, dual outputs, but they just don't always track each other. So one thing you may consider to do to help you out with that is to actually put a converter on the HDR output to convert it into SDR, so you always know what it's going to be, and then you can loop that back into your router and send it back to your camera shader so you can see what it looks like. Well, speaking of camera shading, there's been a couple different changes on this. Earlier on, the thought was that you'd have your camera shader shading in SDR on an SDR monitor, and you let the HDR ride. Thoughts have changed a little bit recently with some more experience where camera shaders have become a little bit more comfortable and can shade in HDR and just have a predictive SDR down convert routed back to them and have an SDR monitor that they can just kind of look at to reference to make sure their shading isn't impacting it in a negative way. Same thing for SDR. I won't go through that in detail, but you can upconvert those and shade them in HLG or HDR, and then down convert them again into SDR to make sure that nothing bad is happening. In graphics, you always need to be concerned about graphics. You know, if you create your graphics in BT 2020 color space and having an SDR deliverable is important to you, graphics probably aren't going to look the same when they're down converted into 709. So that needs to be taken into consideration. So again, round tripping, extremely important for a lot of people these days. Brand colors that are in SDR need to be still looking like the same brand color when they get up converted into HDR and down converted back into SDR. So I recommend making sure you test those conversions to make sure it works the way you want it to. And then lastly, you know, consider what you're using to make those conversions for you. So you need a high quality LUT processor, something with 33 point that supports 33 point LUTs and tetrahedral processing or interpolation. So with that, I thank you, and I know that was a quick run through, but if you have questions, we'll have a roundtable session later where you can ask questions, or you can email me at timw@aja.com. Thank you.